Hey everybody, it's Tony from Adafruit, and I wanted to do a stream on an interesting piece of software that I saw recently. And it took a long time for me to get it working, and so I finally got it working, and I figured, what the heck, we'll turn the camera on and do kind of a little bit of a late night stream on how to use this. So let's see, let's just jump right into, I'll do a little demo of what I got working. So I saw Amazon released a bit of source code for using their Alexa voice service, which is basically the thing that powers the Amazon Echo kind of, I don't know, speaker, artificial intelligence, friend thingy. You know, basically you talk to this device. It has a really cool microphone array. It can listen from anywhere in the room, and you can ask it questions, you know, say like, okay, Alexa, what's the weather tomorrow? And it'll tell you things like that. So real fun device. I'm sure a lot of folks have messed with it. But the neat thing is that Amazon has a web service where they actually let you use the same functionality and intelligence of Alexa with your own hardware. So like if you can record some sounds, like a question, you can send it to their service, and then they'll send you back a reply that's like a sound file that talks the response to the question that you asked. And so they published some source code on, you know, how to use this with a Raspberry Pi. And I went through it. It's a little bit complicated, and I'm not going to actually do the whole install on this stream because honestly it took me about 5 hours or so of futzing around with things. And I like to think that I know a little bit about what I'm doing, so it's not what I would say an easy install. There are a bunch of issues that I'll kind of walk through as we look at it. But first, let's just do a demo of it because I'm hoping it's still working. It's very touchy, so we'll jump to the workbench real fast. And I'll just kind of show you what I've got here. So this is a Raspberry Pi Zero. So this is a slight change. The instructions that Amazon has call for using a Raspberry Pi 2 or even 3. Maybe they don't even mention 3. But I think that they're using that because it has its built-in microphone input. I wanted to make things hard, so I figured let's do the Raspberry Pi Zero, you know, slower processor, see how things work. Now I've got it hooked up to, this is a little USB hub, and this is the USB on-the-go adapter, so you need this to talk to the Raspberry Pi to plug in USB hardware with the Zero. This is a special hub that we have in the shop, and I'll put links in the description below when this goes up on YouTube. But this has an Ethernet port on it, so I'm connected to my network through Ethernet. You could use Wi-Fi, you know, anything, but you do have to have an internet connection to use this Alexa service. And then plugged into it is this crazy thing. This is a Zoom H5, which is a nice little audio recorder. And it's plugged in through USB. So the reason I'm using this is that it has a cool mode where it can act like a USB speaker and microphone. So it's got a real nice little microphone array on the top here, and you can plug in audio and stuff on the bottom here. But I'm just using it for convenience. So it can play sound and it can record sound. You can even hear like the levels on it right now. It's listening to me. I also have this little guy here. So this is just a little USB audio adapter. So it takes like a microphone input and a speaker output on it. And these are pretty common. We have one in the store also. It's a C-Media chipset. And this should work. I had some problems and I finally figured out a way to make it work. But I just so happen to be using the Zoom. The annoying thing with this is like, you know, you've got to have a microphone and a set of speakers hooked up to it too. So it's, you know, not as easy to use as the Zoom thing, but this is just a little proof of concept of things. So, okay, let's see if I can get this thing to work. So let's jump to the desktop view and we'll put both of these back on. So, okay, on the desktop here, in the background here, I'm connected to my Raspberry Pi Zero through a VNC connection, and I'm running their sample application. Now it's distributed as a Java application, so you have to run a Java app, and it's this little GUI application here. It's not a command line thing, it's a GUI. You actually have to press this button for it to start listening. You speak whatever you want, then you press it to stop listening, and then it'll go and process your command. So it's not like an Echo. It's not just always listening. You can't just say, you know, hey Alexa, what's the weather? something like that. So and I think that's actually by design. From what I understand, I heard this. I haven't read it myself. This might be total hearsay, but I think from what I understand that Amazon restricts access to the Alexa voice service. If your device is always on and always listening, then I don't think they technically allow you to access it, but I might be totally wrong on that. It's just I read somewhere, I think like there's some home automation things that want to use this, but they might not be able to because they do that. So anyways, though, okay, let's try to do this demo. So I'm going to click Start Listening, and I will warn you, it is very flaky. It gives a lot of errors. It's a little touchy, but I'll speak a question, and then it'll play it back through the Zoom recorder that I'm just holding here, and I'll try and hold it near the microphone here so that you'll be able to hear it. So, okay, let's see what this does. What's the weather in Seattle? Okay, that didn't work. Let's try that again one more time. Oh, now we get a new error. So you can see this is a little bit touchy. It's Java, and it's Java Sound, and it's Linux, which put all three of those together, and it is a bad combination. But let's try this again. What's the weather in Seattle?
In Seattle, Washington, it's 51 degrees with clear skies. Tonight, you can look for just a few clouds in the sky and a low of 42 degrees.
Okay, so that worked. It answered the question, and you can see it sounds just like the Echo if you've ever used one. It seems to give the right response, like it's telling me the weather. Let's try again, and it seems like every other time I run it, it fails. So we'll try this again. Tell me a joke.
Ghosts, bad liars. Because you can see right through them.
Okay, so you kind of missed that, and it seems to be a bug I've noticed where when it plays back sound, it clips like the first second or so, or you miss the first part of the audio, and maybe even when it's recording. I don't know. That's a good question, but let's try it again. Let's see if we can get something that's understandable. Oh, now we see another error, so this is kind of fun. Let's try this again. Tell me a joke.
Take a sick boat to the dock.
Ah, I see. Where do you take a sick boat? To the dock. Okay, cute. Good one, Alexa. So that's the demo at least. You can see it working. Now, what I wanted to do in this stream was just run through their install. I'm not going to do it, but I'm going to talk through, because I kind of found the installation for this, I would classify it as pretty challenging just because this application is actually like three different things. So there's a Node.js application that's running here. It's this little thing down here. And as far as I can tell, this is only used to do the OAuth authentication. So it's a little weird that you need a full-on Node.js app just for that, but that's the way it is. And then there's this Java application that you've got to run, and getting Java to run on the Pi is already a kind of a mountain you have to climb up. So there's a little bit of pain here. The instructions seem to be written by someone that was probably using the older Wheezy distribution, because now in Jessie, the latest version of Raspbian, a lot of these instructions don't apply anymore, and in some cases it actually caused me a lot of problems. So I'll kind of walk through and say like what worked, what I did, what I didn't do. There are a lot of steps to this though, so honestly it'll probably take you at least 2 or 3 hours to set up. You have to go into Amazon's web service web page and create a little demo application. There's all kinds of steps to do, and if you miss one little step, there's not a lot of error checking. It's not going to tell you this is what's wrong, so like you're going to bang your head against the wall for a while. So just a fair warning, this is not a beginner application by any stretch. But I'll put a link to this. This is the GitHub repository that has the code that Amazon has for this. Talks a little bit about it, talks about what you need. They recommend the Raspberry Pi Model 2. There's no hardware reason why you need the 2 though, and I've got it running on the 0 here. It seems to run fine on here. The 2 and the 3 though, they have an audio interface built into them, so you can just plug in a set of speakers and a microphone, and that should just work. You won't have to do a bunch of config nonsense like I had to do here, because on the 0 you don't have an audio interface, so I've got to use like a USB interface for that, which makes it a little more challenging. I'm going to show you there's some config you have to do. And then other standard stuff, you need USB power cable, good power supply, micro SD card. They tell you to use the Noobs, new out-of-box operating system. I would say ignore this, go straight to Raspbian Jessie. Don't use Wheezy, use Jessie because it has more software installed. There's less stuff you have to do for the setup. It says an Ethernet cable, so like you need a network connection. Wi-Fi would probably work. I mean, maybe it's going to be a little bit slower, but I don't see any reason why it wouldn't work. Now they mention a USB 2.0 mini microphone, and they even link to one little thing on Amazon here. And this is kind of a particular thing. So I think if you want things to just work, you probably want to use the microphone that they link to. And the reason for that is it looks like their software, because it's using Java and Java Sound on Linux, it's not very flexible, and it requires that the microphone is a monophonic 16-bit signed little endian integer data rate. And if your microphone is not that exact data rate, you're going to have a lot of problems. Now, I found a way around that. You can configure also, which is the sound interface in Linux, to automatically do these conversions and use a different type of microphone, but it's kind of like weird, and I don't know if it's always going to work. So, you know, like if you just plug in a random USB audio device, you're probably going to run into trouble if it's not like a mono, you know, sound microphone input. You know, like I would bet like a headphone, like a headset that has a little microphone on it, probably would work. Like that's probably monophonic. But like my fancy Zoom right here, this thing's stereo by default, and that causes problems. It doesn't work at all, unfortunately. You get these errors. And then you need a mouse and a keyboard. So, and they say to plug into an HDMI monitor. I was able to do this without an HDMI monitor plugged in, so it's not necessarily required. But it is annoying in that it's a GUI application. It's this little Java thing that runs here. So you're going to have to, like, I'm connected through VNC, and when you read these instructions, you start looking at this like, what the heck? You need to VNC into this thing to run some software? And yeah, you really do, unfortunately, because it's a GUI. So, okay, skills you need: basic programming, familiarity with shell. Yeah, you need that. I would also add, you probably want to be a little bit patient and be able to Google for problems and things that you run into. Okay, so the setup, you know, get the Raspberry Pi, get your SD card burned, install it, run Raspberry config, expand the SD card, you know, log in, make sure everything's working, get a good Raspbian image going. And then let's see. So let's go through. So they talk about booting up the Noob's operating system and then installing Raspbian. So, you know, skip that. Just go straight to Raspbian Jessie, in my opinion. Now installing dependencies. So they have you do this through the HDMI monitor. I just SSH'd in because one of the first steps here is they tell you to enable SSH. And this is kind of a red flag that whoever wrote this was probably using an older version of Raspbian, because the recent versions of Raspbian, like in the last year or two, automatically have SSH turned on. So, you know, they were probably using Wheezy or some old version of it. And so you don't actually have to do this anymore in Raspbian today. Enable SSH, skip this step. Like you can actually just SSH right into the Pi, skip the HDMI monitor, and just start, you know, talking and configuring it. Like right here, I have an SSH connection to my Pi for this. So okay, so then this step, like they have you get the host name, figure out the IP address of your Raspberry Pi. You know, you can do this. You can look at your router config page to figure this out. Ultimately, you just need to SSH into your Pi. And then the next step, they have you install Tight VNC Server, which I did that. It makes sense to do that because you do need to run a little GUI application on here, and VNC is kind of the easiest way to do that. Then they also have you configure VNC to run automatically at login here. And it's kind of funny the way they have you do it. They add a desktop entry to your auto start folder for your X11 desktop. I don't know. I mean, there are lots of ways to make things run when the Pi boots up. I guess this makes sense because you need your desktop app, you know, like you need to be running the GUI, and so when it runs, it can automatically run Tight VNC. And just as a side note too, you can't use the light version of Raspbian Jessie. You need the full version because you need the desktop. Like, you know, you need to be able to see this whole graphical GUI here. The light version doesn't have that, so use the full version. So yeah, this is okay though. Follow their steps to get Tight VNC to run automatically on boot. One big thing though, don't skip this little thing that they don't really mention. After you install Tight VNC, you need to run it once because it's going to ask you to set a password. If you don't run it and you go through and you add this config, it's not actually going to run on boot. So you need to run it once yourself to set the password and all the config, and then it can automatically run on boot. So that's something that could trip you up a little bit. Then it talks about, okay, connect using a VNC client, and that's fine, that's normal. The next step, they have you install VLC, and I honestly have no idea why they have you do this. I'm not sure what uses VLC in this app. It seems to use Java Sound, and as far as I can tell, Java Sound doesn't use VLC. But just to be safe, install, run this sudo apt-get install. It's going to install VLC. They have you also do, let's see, if you've already installed it, they tell you to do some weird commands here. I honestly don't really trust what these commands are doing, so I would just start from a fresh, clean install and not run these commands. Let's see, they also tell you to check where VLC is located. Okay, that's fine. They have you set these load library path and VLC plugin path folders. So the weird thing about these instructions, they're telling you to do this in a terminal. They're telling you to set these, basically export LD library path and set this. So this is going to change just in this terminal session, your LD library path and VLC plugin path locations. This isn't going to persist across reboots. So I honestly don't know why they're having you set this because, as far as I can tell, VLC isn't used. So I don't know. I did this. I don't think it's doing what they think it's doing, unfortunately. But hey, it's there. It doesn't hurt to do this step, at least. So it's there. Now this load library path, this is basically where Linux looks for shared libraries, like DLLs in the Windows world. So, usually when you run a program, you sometimes might get an error that says like, hey, I can't find, some library I depend on. And the way you fix that is you set this load library path to point at the folder that has that shared library. Usually it's a hack when you have to set this yourself because your software hasn't been installed correctly. So I don't know. These steps are here. It's okay to follow them, but it doesn't give me a lot of warm fuzzies that these steps are here. So, but you can basically see it's telling you, okay, to check this path. Now the next step. Now here's where you need to be careful. So it's telling you to install Node.js. Now if you're using the current version of Raspbian Jessie, it's already installed and you don't need to do this. And in fact, if you run this command that they have here to install from this nodesource.com repo, at least on the Pi Zero, it broke Node.js for me. It seemed to install a version that's not compatible with the ARM v6 architecture that the Pi Zero uses. I think it would still work on the Pi 2 because I think it installs the ARM v7 version. But just fair warning, I would not follow these steps at all to install Node.js. So here's the way I install Node.js on the Pi. So use Raspbian Jessie, the current version, and you'll actually have Node.js installed already. Like if you run node-v on the Pi, it'll tell you this, like v0.10.29. Now, fair warning, this is an old version of Node. Node.js is actually up to like version 5. They renamed like last year. They went from like v0.11 straight to v5. Or v4, but it's up to 5 now. But that's okay because these instructions for the Amazon thing seem to depend on Node version 0.10. So it just so happens that Jessie has the right version and we're all good. But you do need to install npm, the Node package manager. So you want to do a sudo apt-get install npm. And I've already got it installed, but run this and that'll install npm. And then you're good. So don't do anything else in their steps here. Like don't run this deb source. This is going to install like a version of Node that might not even work on your Pi. So fair warning on that one. Now the next step, again, is another problem where, so it's telling you to install the JDK, the Java Development Kit, and it's telling you to go and download it from Oracle. But the thing is, on the current version of Jessie, this is already installed, so you shouldn't run this step. So just skip right down to checking the version, this Java-version. So on a brand new Raspbian Jessie install, and it's the full Jessie version, not the light version, you should automatically have this. So this Java-version, and the big thing to look for is Java version 1.8. So that's like Java version 8. That's the version you need for this. So make sure you see that. So skip these steps. It doesn't apply. It shouldn't hurt to install these, but you're going to waste a lot of time doing this. The next step, install Maven. So Maven is like a Java build system. And these steps are fine. Like follow their steps here that they have here. They basically have you download it. You unzip it. Make sure to unzip it to the /opt directory like they show here. And then they also have you change this etc profile config so that it sets these environment variables. Now this is where, like, if they were setting these LD library environment variables, you know, for VLC, you could put that stuff in here, but I didn't do that. It seems to work fine without it. I honestly don't even think VLC is needed for this. Maybe installing VLC installs a dependency that Java Sound needs to work, but you know, I'm not exactly sure what they're doing. Okay, so the next step, this part takes a while here. So you have to do all this setup on Amazon's website. Oh, and also as a fair warning, they kind of slipped this step in here, hidden in the web setup part. But you actually need to download the code for this sample application. They tell you to download it from the Git repository. So don't skip this step here. It's easy to gloss over this, but you need to download the code onto your Raspberry Pi. And then it has you go to this Amazon developer portal here. So let's go here, and I'll just kind of show you. Let's see, you have to log in here. Let me sign in with my account. And so after I sign in, let's see, yeah, no, don't save that. Then you need to go into the apps and services and the Alexa app. And then inside of here, it's going to give you the voice service, which is what you want. And here you create a device. And so I won't go through it all. Follow their steps in the guide. They seem to actually be good and documented well. Like, it tells you step by step how to go through and create this. Fair warning, create everything exactly how they say in the guide here. Like, don't change anything. So even when you see weird things like device ID equals my device, use exactly this my_device, because later on you have to generate certificates, and if you've changed any of these values, it's going to change how you have to generate those certificates. Things aren't going to work, so follow their steps exactly here. So like on my account, I started out, I thought I'd be fancy and create something with a different name, and that didn't work. So then I went back and created one using exactly the name they have here. So this is the thing that I created. And as far as I can tell, like, it seems like you have to go onto their portal online and create like a device, and that creates like some state online, like it has a device ID, and then you'll create all these certificates locally on the Raspberry Pi that refer to this thing. So it all feels a little bit enterprisey. Like, there's a lot of weird little steps to go through for this, but follow them and it should work. It just, be very careful to follow everything exactly as they say here. Okay, so you know, these are all these little steps you have to go through to set the security and stuff for this, and it's all kind of boilerplate stuff. So I'll just kind of skip through this. Now the next thing, so generate self-signed certs. Tells you to install OpenSSL. I noticed it was actually already installed, so that's fine. There's no problem there. Then it has you go in, and so the source code for this thing, it's in this Alexa directory, and there's a samples folder, and there are like 4 different applications in here. So there's an Android app, an iOS app, and I haven't used either of these. I'm not exactly sure you know, what they do. This companion service is a little Node.js application that runs, and I think from what I can tell, it only does authentication stuff. And then the Java client is like the main actual client application here. So these are the 2 that we'll deal with. Now this tells you to run this certificate generation step and follow this instruction exactly. So, you know, run the cert generation. The one thing that it didn't really clarify here, though, so it tells you in this step, edit the file ssl.cnf and fill in the appropriate values where it says your underscore. So like, let's look at this file. So let's go into Java client and let's look at this ssl.cnf. So down here under this country name and state or province name, this is actually where by default it'll tell you, it starts out with like, you know, your country name here and your state name here. Now these values have to be set to the 2-letter kind of abbreviations. So for the country US, don't put like United States, don't put USA, you have to put US exactly in here. And for your state or province name, it has to be the 2-letter abbreviation. So like for Washington, WA. If things don't work for you, or if you're confused, use the values that I have here, because honestly it doesn't matter. This is just generating a little self-signed SSL certificate for that little Node.js server that runs. So it's a little weird why it even has to do this, but something requires SSL, and it's got to have these certs here. Organization name and unit name don't matter at all here. You can put whatever here, but be sure to use the 2-letter abbreviations, because what happened was I didn't have, I wasn't sure what to put here because the instructions don't tell you what you need to put in here. So I just put in, okay, like USA and Washington or whatever, and it'll actually fail to generate the certs, and it fails in a very unintuitive way. You get this like max string length exceeded error from OpenSSL, and it's not obvious at all what's going on. And so I was just kind of lucky that I happened to hit on the issue here. So word to the wise there, be careful about how you configure that. But then once you do that configuration, you can run this generate.sh shell script. Fill in the values they give you exactly. So, give the product ID as my_device, because I believe this product ID will actually match what you configured in your web service or in the Amazon Web Services up here, like this my device value here. So that's just a warning there to use that. The serial number, it also has to be 1, 2, 3, 4, 5, 6, because later on in the configuration they use this value. The password you can actually set to anything. They have talked to me. I put in Raspberry because that's just the password for the user on here. Then you go through and you have to set a bunch of configuration files. So both the Node.js server and the Java client have separate configuration files. They all need to reference these keys and configurations. So I'll show you like the config.json for, this is the Java client in my case. And so this has, here's like the device name that you have to set, the device number, which is set like the instructions say. The important thing here is like this SSL key store. So this is the path. And it has to be the absolute path, the full path. You can't put like a tilde, kind of shell location in here. So this is the full path to this jetty.pkcs12. The shell, the certificate generation script actually generates these things. So that's where those files are created. So yeah, be very careful, follow their instructions exactly. It's a little bit annoying. They have you jump through each of the configuration files a couple times. The next step, then they have you go into the companion service and run npm install. That's fine. That just tells npm, the node package manager, to install all the local dependencies. Okay, now the next step, then you go back to Amazon's web service and you go back to this portal URL, and you have to do a few extra steps in here to tell it, here is this my sample application that I created. And it's kind of funny, they just tell you to put in like a junk URL for this. There's all these weird little boilerplate steps where, for a simple demo it's way overkill, but unfortunately you just have to do these things. So follow their steps. All this stuff seems to work fine for me. So they have you do all this stuff. Then here they tell you to VNC in and start editing the configuration files. I'm not sure why they have you VNC in at this point. I was editing these configs. Oops, let me go back. I just pressed the mouse button on accident. I was editing these through SSH and it was fine. So to edit these files, it's fine to use VNC like they show, but it's a little weird and slower, and you can't copy and paste through there. But again, this has you go back, and you're not done editing config files. You thought you were done before, but no, you have plenty more config files to edit at this point. So now you have to go in, and in the previous step you get these magic client ID and secret values. So then you take those and you paste them into your configuration file here, and then don't skip this little step here, this product step, where they have you fill in the name of your product and the key inside of here. It almost, it'd be nice if they could just have pre-put that into the configuration. Like obviously your secrets are going to be different, but I'm not sure why they have you fill this in, but hey, it's there. Follow that step, save that config, has you go back and edit another configuration file here. So go in and do that configuration. It has you edit this pom.xml file, which is a Java dependency thing. I don't know why the file just doesn't include this already, but you've got to go in and add this dependency inside the file. So add that, save the file. Now at this point you're ready to start running the software. And here I'll close it, and I'll go through kind of what you need to do to run it. So let's see, let me close this, let me exit out of here, let me exit out of their app, and exit out of that. Okay, so now you do need to be logged in with VNC, like on a graphical, in the desktop, because you're going to run this little Java GUI application. So now let's open a terminal, and we need to go into the companion app, which is the Node.js application, and basically we just need to tell it to start. So you need to go into that Alexa folder, and then the samples folder, and then the companion app, and you run npm start. So that tells the Node package manager to run the start script. And this will spin for a little while, and then it's going to run, and I believe it's just running a little local web server that seems to do authentication stuff on port 3000. I'm not really familiar with OAuth. I think it's OAuth 2 that they're using here. I would hope there's a better way to do this, but I've read a lot of bad things about OAuth. I think OAuth 2, I think one of the creators of OAuth 2 actually walked away from the spec because it turned into such a weird thing that doesn't do what anyone ever intended that he just gave up on it. So I don't have a very good opinion of OAuth 2, but hey, it's there. I don't know. There's nothing better. But for some reason, it has to run this little server for OAuth 2 to work. If you were going to build your own version of this, and ideally, I'd love to have a little command line app I could run and not have this GUI app. It's probably worth looking into, are there libraries or things that take care of this OAuth junk for you, because it seems a little weird how they do the OAuth stuff here. Anyways, though, so you run this thing, and it's got to be running, so let that run. Now open a new terminal, and the instructions say exactly to do this, so I'm just following the instructions. It is kind of funny in their instructions. They get a bunch of errors from Node.js when they run it, I think because they're using an older version of Node. But anyways, okay, so now you want to go in and run the Java client. So, okay. And at this point, I should also probably say, so if you're using a USB sound card, you want to go into the configuration here in preferences and your audio device settings, and you want to make sure that you see your sound card listed here. So like this is the Zoom H5 that I have right here. Typically, by default, if you haven't changed anything, you'll see like the BCM 2835, like the Raspberry Pi audio hardware. And so you probably don't want that. So you want to select your sound card and click the Make Default to make it a default. Now the other big step that I had to do, because I'm not using a monophonic microphone, I actually had to tell ALSA, the sound configuration in Linux, how to do the conversion of sample rates. So I'll show you what I did. So on the Raspberry Pi here, I edited the home directory.asoundrc, and this file, it's created after you go through the preferences and the audio device settings. If you click Make Default, I think it creates this file, or you could create this file yourself, but I'll show you what my file has in it. So at the top here, I actually commented out, this was what I had by default when I first started. So this is just saying your default sound device, PCM default, is the hardware card 1 for ALSA. And then I've changed it slightly. So the other thing with ALSA, if you're wondering like, okay, what are my cards that I have? Run aplay-l, and this is going to list all of the cards that you have enabled with ALSA. Now I only see card 1. You'll probably see card 0 and card 1, but I've actually disabled card 0, and I'll show you how I did that in etc modules. Let's see. Oh no, it wasn't there. How did I? Oh yeah. So in the /boot/config.txt file, way at the bottom here, there's this enable audio, and this will actually be uncommented for most users, like a default Raspbian install. And this just says use the default Raspberry Pi sound hardware. But because I'm using the Zero and it has no sound hardware, I actually commented this out to just completely disable the sound on the Raspberry Pi. So that'll prevent programs from getting confused and trying to use, the non-existent sound hardware on the Pi Zero. So I commented that out, and so that got rid of my card 0. And so now I only have card 1, which is my Zoom H5, this little USB device. But it's kind of weird. I mean, it doesn't get renamed to card 0. It happens to be card 1. There is a weird way to rename these, but I'm not going to try it. But anyways, so to go back to that asound RC file, so the problem I ran into with this default config is that it's basically telling ALSA, just talk directly to my sound hardware. So if a program wants to play back a WAV file that's like stereo sound at 16 kilohertz, my sound hardware has to support that or else it's going to fail. And, the Zoom, it seems to support playback of a lot of different formats. Like, it's a nice little audio interface, so it wouldn't surprise me that it supports pretty much every format. But the other side, the flip side of that, for the microphone, for recording, this default config up here, this type hardware, also means that if a program asks to get audio from the microphone and it's in a format that your microphone doesn't support, it's going to fail. It's not automatically going to convert things. So like this Zoom recorder, it seems to output stereo sound, at like 16 kilohertz, or actually it seems to be 48 kilohertz, it says on there. So, it's nice high quality audio on this thing. The problem is the Java application that's reading the microphone, it's not very elegant, it's not very smart, and if it asks to get mono sound at 16 kilohertz, and if that fails, it explodes. Like, it just doesn't run. It doesn't know how to do conversions in software and stuff like that. So that's a problem. That's annoying, unfortunately. And it took a while, but I kind of figured out. So you can basically tell ALSA, the Linux sound configuration, to do software conversion. So, it is possible to convert from like 48 kilohertz sound to 16 kilohertz sound. You just have to change your sample rate a little bit, and you can do that conversion. And ALSA knows how to do that stuff. It's just by default, when you tell it to talk directly to the sound hardware, it's going to assume that you don't want it to do any of those conversions. So this little block of config that I did here, I'm basically saying, okay, change my default audio device to instead don't talk directly to hardware. Now I'm using this plug type, which I think is like a synthetic, or like it creates an audio interface. And the slave device, so it's kind of like a pass-through. It's like, turn my default audio device into a pass-through that talks to another audio device on my machine. And that audio device is this plug HW:10. And the super important thing here is the plug HW part, because this HW alone is actually, that's a valid ALSA sound card, and that's actually saying use card 1, like that, my Zoom H5. But without that plug in front, it's not going to do any software sound conversions. So if I put plug in front of here, then it actually tells ALSA, okay, if a program wants like monophonic sound at 16 kilohertz, but the hardware only supports stereo sound at 48 kilohertz, that's okay, I'll do the conversion. ALSA, like the kernel, will do that conversion itself. And so that was the magic thing that I had to do to basically tell my default sound device, hey, be smart, it's okay to convert, audio, do that conversion if you need to. And honestly, I don't know why it doesn't set itself up to do that by default. Like in Windows and Mac and all these systems, they try to do what works for users. And here in Linux, it's, basically like, I'm sure from a hardware perspective, this makes total sense of like, well, if you don't want me to do these conversions, I'm not going to do them unless you ask me. But, how about we make things easier for people for a change? But anyways, that's the config that I had to use. If you're using a Raspberry Pi 2 and you're following their tutorial exactly, and you're even using the microphone they use exactly, you probably don't need to do anything. But if you start getting all these weird sound errors, try what I just showed, change your default also sound device to be that plug HW device, and that'll probably fix the issues for you. So, okay, so now we're ready to run this Java app. So let's go in and go into that Alexa folder, we'll go into the samples folder and go into the Java client folder. And now we want to run, and it's a little weird how they have you do this thing. So in their instructions, and I should also say here too, so in their instructions, they actually have you run this install java8.sh. And at first I skipped this because I'm thinking like, whoever wrote this was using an older version. They didn't realize Java 8's already installed. And I tried things, and things were failing, like it wasn't working. When it runs, it actually is supposed to pop up a little dialog that gives you a URL to go to on the authentication page, and I wasn't getting that dialog, and it was running the app, but it wasn't failing, and it was really weird. And I realized, because I skipped this step, that was the problem. So this step will actually install Oracle's version of the Java runtime, which I think by default it seems like there's an open source version. And it's a very subtle error. If you have that open source version installed, the default one installed, you might notice there's an error when you run it. It says there's like an SSL error where it doesn't have the right SSL, I think like encryption algorithm or something installed. And because of that, it seems like it doesn't generate this special URL that you need. So anyways, word to the wise, they're not kidding when they say you have to run this install java8.sh. So run this. Seems a little weird that you've got to go and install Java 8 again, but just do it. You need to do it. Then they have you run this maven validate command. So that tells it, I guess, to check that the app has all the dependencies. Then you run this install once to install the dependencies. And then finally, to run the application, you run this maven exec:exec. So let's run that. mvn exec:exec. Oops, spell that right. So now let's see. And this spins for a little while. It takes a while for it to run. And so then it'll kind of show you. So when it runs, the first time you run, you should see this pop up like they show here. That gives you a URL to go to. So if you don't see that, then you probably skipped that Java 8 install step. So go back and make sure that you didn't miss that. Okay, this is still running. It takes a little while. It's running. I think Maven is for some reason it seems to download the dependencies every time I run it, which doesn't make sense. But I don't know. It's Java. I don't deal with Java much, so it's kind of interesting. I started also to poke at the code for this thing, and ultimately, all that this thing needs to do is record sound, send it to a web API that Amazon has, and then get a sound file back from that web API and play it. And so they've created this whole Java application, which it's not bad. I mean, it works. It's a little complex, though, when you look at the code. It's full of classes and things. So, it's a little complex, but honestly, I think this could be replaced with one or two Python scripts that call a play and a record and just record and play back audio using the built-in stuff. So maybe in the future I might take a stab at making a simpler version of this, because I'd also like to have a version of this that you can run from the command line and you don't have to have a GUI application for. But anyways, so yeah, just word of the wise that the app it's a little bit of a quirk to it. Okay, so I ran this and I got this dialog. So this is telling me to go to this URL here. And this is actually a URL that little Node.js server down here is hosting. And from what I can tell, it seems to be the only reason this server runs is so that you can access this URL here. So okay, let's do that. So we'll go to the web browser here, and I need to paste in the token that I got. Now this is going to do some stuff, and it's going to bounce you to Amazon's website. And so this is actually where OAuth is doing its magic, and it's authenticating you. So you have to log in. Let me log in with my name and password here. And the first time you do this, there's an extra step they show in the instructions. You have to give access to this. But when it's done, it's going to come back and say, okay, device token's ready. So that's cool. Now I can minimize this. Now I hit OK on this. And now finally it's running. So after all of that, it's ready to go. And now I've still noticed that it's a little buggy. So the way I understand it's supposed to work, you click start listening. You'll hear a tone like a beep, and that tells you to start talking. And then you ask your question, and then you click stop listening, and then it goes and processes it and plays back the thing. But sometimes I've noticed the tone doesn't play, or I don't know, it skips playing it, but it still records it, and it still seems to work. Sometimes I get that error that you saw, that signed 16-bit thing. I don't know what's up with that. So anyways, well, it's a little flaky, but let's just try this again. So let's see. What's the weather in Seattle? So you can hear the sound was a little messed up there. Oh, that's interesting. It looks like it must not have recorded anything. So let's try it again. Let's see if this works. What's the weather in Seattle? Didn't even play the sound at first there. So, wow, it's a little bit messed up. Let's try this again. What's the weather? Oh, didn't even work.
Washington, it's 51 degrees with clear skies. Tonight, you can look for just a few clouds in the sky and a low of 42 degrees.
Okay, well, I mean, it sort of worked there. Let's see if we can get this to work again. Tell me a joke.
Flags say to the other, nothing. It just waved.
What did the flag say to the other? Nothing, it just waved. Okay, I think that's what she said. So again, you notice it seems to be cutting off a little bit. I think that's probably a bug in ALSA, because I've done some ALSA it's not a bug in ALSA, rather. It's a bug in how they're using ALSA or whatever. I've done some ALSA programming myself, and it's very easy to run into those problems. Like if you get back a buffer of wave data and you don't interpret it the right way. So I'm not ready to say that it's a fault in their app. I mean, maybe it's how I've configured ALSA to do those conversions and stuff. So there's a lot of stuff that could be going wrong, unfortunately, with that. But like I said, I think this could be greatly simplified into maybe some shell scripts or Python scripts that just use some of the tools that are built into Linux. Honestly, I wouldn't use Java for this, because Java is not really made to do cross-platform sound and stuff like that, because sound is so hardware specific and operating system specific that basically when I started to run into problems, I started to Google for Java sound, and every single Java sound Google response I saw was basically, don't do sound with Java in Linux. It's completely broken. So not a good vote of confidence there. But it does work. It is pretty impressive and cool that they've got this voice service. This example code, it's complex. You're going to want to spend some time following this. I would not say this is for beginners. If this is your very first Raspberry Pi thing, you're going to be very frustrated. Get familiar with doing some Pi stuff first. And honestly, wait a little while. I bet in a few months, someone's going to make a better version of this that doesn't use Java and doesn't depend on this Node.js stuff. I think this could be a lot simpler for this, but it's kind of cool. I mean, it's neat that they've opened this up. You can go and, with a little bit of pain, you can get this to work, and it's running on the Pi Zero, because the Pi Zero itself is not doing any of the speech and and artificial intelligence stuff here. It's really just recording sound, sending it to Amazon servers, and then pulling down a sound file from Amazon servers and playing it back. So, you don't need a fancy machine to do this. You just need something that can record audio and play it back. So I think that's it for the stream. It's a little bit late. Unfortunately, I spent way more time getting this set up. Mostly because at first I thought, oh, I know what I'm doing. I'm going to skip all these steps. And then I realized that some of these steps you can't skip. So, hopefully this video helps some folks that can, want to go through and follow the steps. Just in general, be careful, follow every step that they have, except where you shouldn't follow them, installing Node.js and some of those things. And so, yeah, just be kind of careful, because it looks like these instructions were written more for using the Wheezy version, and now things have changed a little bit with Jesse. And also try to use a monophonic USB microphone if you can. That'll probably give you less problems. But if you can't, try that little ALSA hack that I showed earlier and see if that might work for you. So I think that's it. I think I'll wrap up the stream then. Definitely subscribe to youtube.com/Adafruit. You can see this video and all kinds of other fun videos. Check out twitch.tv/Adafruit. You'll see when I do live streams like this. The next stream I'll do on Friday. So I've been doing a series of videos on creating an internet thing with the Raspberry Pi. And so we've done 2 videos so far, and have a neat little thing where, it's a web application that runs on the Raspberry Pi, and you can turn on and off an LED and read the state of a digital input with it. So some fun stuff there. So yeah, tune in this Friday. I'll do that. And then of course we've got all the other shows and things going on. So stay tuned for Desk of Lady Ada. Usually do that a few times a week. Noah and Pedro have Layer by Layer, and then also Wednesday tune in for Show and Tell and Ask an Engineer. So it starts at like 7:30 Eastern for Show and Tell, and then 8 p.m. for Ask an Engineer. So that's it. Tony from Adafruit, and have a great night and have fun with Alexa web services on the Raspberry Pi.